Hi guys, so today we'll be talking about calculating and interpreting the Pearson's product moment correlation coefficient. So in Pearson's product moment correlation, we have Pearson's R, which basically tells us how much one variable changes as the values of another changes, and this is in their covariation. So typically this requires an interval or ratio data, and there's also two scores from each participant are needed and cannot be separated when we are analyzing this, because this can interrupt how this correlation is observed, and it could skew the data, or it could not necessarily tell us enough about one variable changing and its effect on another. So this requires participants with only one score cannot be included in the analysis because it's not enough. So we do require to when we're looking and analyzing Pearson's product moment correlation. So there's many limitations to Pearson's R. So typically, in this, correlation does not equal causation. So even if the correlation is perfect, it still does not lead to a cause and effect type of relationship. So we can't necessarily make an assumption that even though it's perfect, that it's still going to be the reason for it. Um, Another limitation is it only describes linear relationships. So basically, it doesn't describe data that might go up and then down, and it's like a U-shaped. So when two variables have a curved linear relationship, the R will be near zero mostly, if not all the time. So these are some things we could look at when analyzing Pearson's R. And also the magnitude of R is affected by the variance or range of the data. So variables with a large variance or range tend to have a higher R value than variables with restricted variances or ranges. So this is basically what it means for Pearson's R and how we can interpret the Pearson product moment correlation coefficient.